Good morning, dear students. In our previous class, we have learned how can we convert a binary number into octal and a octal number into binary, hexadecimal number into binary and binary number into hexadecimal. Today we will learn some more conversion and our first conversion is octal to decimal. Okay, so before starting I want to show you some flow chart that I have told you in the first class, then how can I convert a hexadecimal number into decimal and binary number into decimal and octal into decimal. Okay, so if I want to convert a octal number into decimal number, then I will do, I will multiply. If I convert hexadecimal number into decimal, again I will multiply by 60. If I want to convert decimal number into octal, then I will divide by 8. If I want to convert decimal into hexadecimal, I will divide by 16. So all the incoming arrow are representing the multiply and all the outcoming arrow are representing divide. Okay, so we will apply this approach here. Okay, and so first I will take one question, and my question is 3, 4, 5. This is a octal number and I have to convert it into decimal. Okay, so octal to decimal, it is a incoming arrow, and here I will apply the multiply approach. Then how can I apply the multiply approach? What I will do, I will simply divide it by 16 to the power 0, then 16 to the power 8 power 0 and 8 power 1, because this is the octal number, and this is 8 power 2. Okay, so after that we know that 8 to the power 0 will be 1 into 5, then 8 to the power 1 will be 8 multiply 4, and 8 to the power 2 is 64 multiply 3. Okay, it will be 5, it will be 32, and it will be 192. Okay, now if I add this number, it will be 229. It will be our decimal number. Okay, now after that I will again solve one question, and my question is 246. I have to convert this into decimal. Again, this is 8 to the power 0, this is 8 to the power 1, and this is 8 to the power 2, and it will be 1 into 6, it will be 8 into 4, and it will be 64 into 2. Then it is 6, it is 32, and it will be 128. And if I add this 128 plus 32, 130, 160 and 166, it will be 166. Okay, so this is how we can convert any octal number into decimal. Okay, now I will convert a decimal number into octal, and my question is 239. This is the decimal number and I have to convert it into octal. Okay, so for this, what I will do, I will apply the divide approach. Sorry, it is 239, and if I divide it by 8, then it will be 16, 9, and remainder will be 7, then 8, 3, and here will be 5. Okay, so and after that I will move from bottom to top, and it will be 357 to the power 8. Okay, so this is how I can convert any decimal number into octal. Okay, so again I will take one example. My example is 16610, and I have to convert into octal. Okay, so again I will divide by 8. Then what will be here? 8 to the 16, and again dividing not possible, though I will write so here will be 6. If I divide it again by 8, then 8 to the 16, and remainder will be 4. Again I will go from bottom to top, and our answer will be 246 to the power 8. So this is how I can convert any decimal number into octal. Okay, now our next conversion is hexadecimal into decimal. Again it is a incoming arrow, then I will here apply the multiply approach. Okay, so first of all I will take one example. My example is 3A5. This is the hexadecimal number, and I will convert this into decimal. How can I do it? 3A5. Again, what is the meaning of A? A is representing the 10. So I will replace it by 10. This is 16 to the power 0. This is 16 to the power 1. And this is 16 to the power 2. So this will be 1 into 5. It will be 16 into 10. It will be 256 into 3. It will be 5. It will be 160, and it will be 768. If I add all these, then I will get 933. It will be a decimal number. So this is how we can convert any number into any hexadecimal number into. Now our next conversion is decimal to hexadecimal. So I will take one example here. My example is 3509, and I have to convert this into hexadecimal. Okay, so for this I will apply the divide approach. Then I will take 3509, I will divide by 16, and I will write the remainder part here. So 16 to the 32, 3, 0, 16 1 ja 16, 16 9 ja 44, and remainder will be 5. 16 1 ja 16, and 16 3 ja 48, and remember will be 11. Okay, and now division is not possible, so again I will go from bottom to top. Here I will write 13, then 11, then 5. Okay, and student, we know that I cannot write 13. In place of 13 I will write D, and in place of 11 I will write B, and in 5 will be like that. So it will be the representation of hexadecimal. Okay, if so I have already told you that we cannot write 10, 11, 12, 13, 14, 15. We will replace this number by A, B, C, D, E, and F. Okay, so now let's take one more example. Okay, so this is your example. Again I am explain you. When I divide by 16, it will be 219, then remainder will be 5, and when I divide by 16, it will be divided by 13, and remainder will be 11, and then division is not possible. So here I write from bottom to top 13, 11, and 5. and we know that we cannot write 13 in hexadecimal, so it is replaced by D, and we cannot write 11, it is replaced by B, and 5 we will write 5 as it is. Okay, now our next question is 273. It is a decimal number and I have to convert into hexadecimal. How can I do it? Again, 273 I will divide by 16, then here I will write 17, remainder will be 1. Again I divide by 16, it will be divided by 1 and remainder will be 1. Again I will write from bottom to top and my answer will be 111, and it is not a binary number. Okay, if you see only 0 and 1, then it is not necessary that it will always be a binary number. Here you will see 111 and it is representing the hexadecimal number. Okay, so now our last two conversion is octal to hexadecimal. Okay, so let us suppose I take one example here. My example is 3, 5 and 6. This is the octal and I have to convert it into hexadecimal. So here what will I do? Students, please listen carefully. I will convert octal to binary and then I will convert that binary into hexadecimal. Okay, now this is not a complex process because you are thinking that I have to convert 2 times. Then it is not like that. It is a very simplest process. Now because I know that if my number is 3, 4, 5 and 6, then how can I convert it into binary? I will write binary of 6, binary of 3, binary of 5. And to convert a octal number into a binary, we will use what code? 421 code. 421 code. And for 421, 6, 5 and 3. So 4101 110 and 101 and 011. Okay, so we will write as it is. So here the code of 6 is 110, code of 5 is 101, code of 3 is 011. Okay, so this will be our binary. And now how can we convert a binary number into a hexadecimal? We will make pair of 4. So this is 1, 2, 3, 4. This is 1, 2, 3, 4 and this is 0. We can eliminate it also. Okay. So here you will see, and for that I will write, I will use the 8421 code. What do you mean by 8421 code? I will write here first of all 1110. Again this is 1110. Okay, so here it will be representing 8 plus 4 12 plus 2 14. This is 14 and this is 14. Okay, both are 14. Now what I will do, I will replace 14 by E and E because we cannot write 14 in hexadecimal. And at last I will convert a hexadecimal into octal. Then for this I will convert hexadecimal into binary, then binary into octal. Okay. Our question is 17A, it is a 16 and I will convert into octal. Okay, so 17A, A is 10, so I will write 10 here. Okay, so for that, how can we convert a hexadecimal into binary? 8421 code. For 10 it will be 1010, for 7 it will be 0111, or for 1 is 0001. So I will write the code here as it is 0 0 0 1 0 1 1 1 1 0 1 0. Okay, now after that I will make pair of 3, pair 1, pair 2, pair 3, and this is the 0. I will eliminate it also. Okay, and how can we convert a binary number into octal? Again, I will make the code of 4 to 1 code. 4 to 1, 4 to 1, 4 to 1, and 4 to 1. This is 0 1 0. It means it is 2, and it is the 1 1 1. Then what does it mean? It is 7, and it is 1 0 1. What does it mean? It is 5, and it is 0. Okay, at the end our answer will be 572 to power 8. So this is it for today. We have covered all the conversion. So students, keep revise all these conversions. Thank you and have a great day.